Welcome back to this class. Let's consider metallic ores. Most times, metals do not occur freely. That is, they are usually found combining with other elements, depending on their level of reactivity. Those metals that are very reactive are always found in combined states, while some that are moderately reactive, they can be combined at times and they can exist in free states. While some other metals are not reactive at all, those ones are always found in free states. But notwithstanding, the natural house where a metal can be found is known as metallic ore. So we can see that a metallic ore is the natural store from which a particular metal can be extracted. It is like a natural house for that particular metal. It is always in form of a rock. So metals can be extracted from such rock by various methods. So each metal, especially those very reactive metals, they have their own natural ore. And each of these ore has a special name. For example, hematite. This is the natural ore of iron. So this is hematite. This is the natural ore from which iron can be extracted. Cassiterite. This is the natural ore for tin. Cassiterite is the natural ore from which tin can be extracted. Next, we have bauxite. This is the natural ore for aluminium. Next, we have zinc blende, which is the ore of zinc. Next, we have galena, which is the natural ore for lead, Pb. Next, we have malachite, which is the ore of copper. So this is just to mention a few examples of metallic ore. Like I said before, metals don't usually occur in free state, especially when they are very reactive. Now, we have to consider some metals that are always very reactive. So those ones are the ones that are always found in combined state, and they are always found in their ore, natural ore, combining with some other elements. Now, consider the table below. This table summarizes everything. Even the method of extracting those metals from their ore is explained in this table. Now, consider the activity series in the first column. You can see metals are arranged according to their reactivity, the most reactive being on top and the least reactive being below. Potassium is the most reactive element. Now, coming from potassium down to zinc, those metals are always they are very reactive, and so they are always found in combined states, because if you mistakenly expose them to air, they will quickly combine with several other elements in air. Even if they are placed on any surface, they will quickly react with other elements. That is why they are always found in combined state. So the next category of elements, from chromium down to lead, those ones, they are not very reactive as the first batch above. So those ones too, they are usually in combined state. From chromium down to lead, they are usually also in combined state, but they are less reactive. Next, we have the third batch of elements, coming from hydrogen down to mercury, which is hydrargyrum, Hg. Oh, sorry, down to Ag, which is silver, argentum. So those ones too are less reactive. So they can be in free state and they can be in combined state because they are not as reactive as the one above. Then the final batch of elements contain Pt, which is platinum and gold. At times they place platinum on top of gold, while at times they place gold on top of platinum. The most important thing is that both platinum and gold are very less reactive. They are the least reactive elements. They are very unreactive. So they are always in free state. So the method, this third column contains the method of extraction of these metals from their natural ore. So the first batch of elements, which is from potassium down to aluminium, if you see the way this arrow is pointing, so we use electrolytic reduction. That is, by method of electrolysis, we use it to extract them from their ore. Then followed by the second batch from manganese down to Cu, which is copper. We use chemical reduction. That is, we can use carbon to extract them from their ore. That is, method of carbonation. That's what we use to extract those ones. And the final batch of elements from mercury, which is Hg, down to gold, we use heating. We heat their oxides in order to extract them from their ores. So this indicates the different methods of extracting those metals. So now, those reactive metals are always found in combined state. They are found combining with other elements such as oxygen. So that means those metals can exist as oxide. Also, sulfur is among the elements that they can be found combining with. It means such metals can exist as sulfides. And finally, thiazocarbonate 4, which is a radical ion, thiazocarbonate 4 ion. So it means those metals will exist as carbonate salts. So let's go back to our metallic ore, the examples that we give above. Let's see how those elements exist in their metallic ore. Let's see how they exist in their ores. For example, hematite, so which is the natural ore for iron. So this hematite is iron 3 oxide. It means iron exists as an oxide in this natural ore, which is the metallic ore. So it exists as iron 3 oxide. Tin also exists as oxide in its natural ore. So this cassiterite simply means tin oxide. So it's made up of tin and oxygen. So that means tin exists as oxide in it. We are going to extract the the tin from the natural ore. We separate it from the oxygen. So this is the form in which aluminium exists. This is bauxite, which is the natural ore for aluminium. It exists as aluminium trioxide dihydrate. So it is hydrated substance. Now consider zinc blende, which is the natural ore for zinc. So zinc inside here exists as zinc sulfide. So it exists as a sulfide. Similarly, the galena, which is the natural ore for lead. So lead exists as lead sulfide in it. And finally, the malachite, which is the natural ore for copper. Copper exists inside it as copper 2 thiazocarbonate 4. So copper exists as a carbonate in malachite. Thank you. God bless you.